Started now.
Yeah, there you go. So I asked Claudia if they would be willing to present to anyone who's interested. So thank you very much, Claudia and Barbara and Sebastian, for accommodating that. I'm sure it's going to be interesting, so I'll hand it over to you, Claudia.
Thank you very much, David. Thank you for asking us to do this, and thank you for everybody joining today. So I'm going to start sharing some slides and introducing the team that you see here. 1 second. And here we go. Oops. Okay, I assume you can see the slides.
Yes.
Speak up if not. Right. So the company you're talking to today is ExoMatter. And this is the team on the call. I'm Claudia Remlinger. I'm the head of growth of ExoMatter, which means I'm looking after marketing and sales. I'm the one that met David at the exhibition. And then I pass it on to my colleagues, Barbara and Sebastian.
All right. Thank you, Claudia. Just a quick sentence from my side. I'm Barbara. I'm the co-founder of ExoMatter. I'm responsible at ExoMatter mostly for networking, investment, business development together with Claudia Sales. And if you have any question regarding pricing or anything, just let me know. And with that, I pass it on to Sebastian.
Thank you, Barbara. Thank you, Claudia, as well. Hi, everyone. Welcome to our talk today. My name is Sebastián Caicedo Dávila. I am the head of delivery here at ExoMatter, which means that I am leading the team of scientists responsible for all the technical implementations behind our computational material science solution. And I'm here to answer as much as I can any questions that you have regarding the technical aspects or the science behind our product. And thanks again for everyone for joining, and I'll be happy to receive your questions.
Excellent. Thank you. And with that, we kick off. So why ExoMatter even? And now the mouse is stuck. Here we go. So you might or might not know that the number of materials out there that you could use for any product is estimated to be more than 10 by the power of 60, more than the number of stars in the universe. Why am I saying that? It depicts the fact that it's virtually impossible to know all of them and to compare all of them, and very, very difficult to find the best one for your application. And we at ExoMatter have talked to numerous companies. They come to us, and some of them are the biggest companies in Germany where we're based, and they tell us the same tale. We're talking to the material scientists there, and they're saying, well, it is really hard. They're using what they've always used. You know, they got their 50 Excel spreadsheets with the materials they've tested in the lab and they've used in the past. They're looking for voices out there in the press that tell them which way to go. They go through literature, but overall, everybody says to us it's very time consuming. And it's wasting resources because a lot of it is based on lab experiments. And as we know, lab experiments take a long time, and it is not always easy to progress fast with them. So this is why we came up with our idea of ExoMatter. And what is ExoMatter? ExoMatter is a platform for materials research and development. Basically, it is a very large database behind the platform. Currently, we have about 1.5 million materials in it. Where do these materials come from? They come from scientific materials databases globally. So we research what's there. For some of them we pay, some are open source, and we combine them into our platform. Then what we do with them there is we make them comparable, we enrich them with machine learning, and then we offer them to our customers. So the materials in database are not just materials that have already been produced, but they are also simulated materials that have never been produced before, and as such offer a lot of potential. So again, in the 3 columns, we do data mining, which means we go out and get the data from various data sources, make it comparable. We enrich it, and that's a critical part, so that our customers can search the data by chemical properties, by physical properties, by engineering properties. We also add data on cost and sustainability, and we add data on literature and patterns of the materials where it's available. And that enables our customers to shape their queries very detailed, as we'll see in a minute, and we'll hopefully give them the right answers. This is what the dashboard looks like in our platform. So you can create your individual searches based on your applications. The system then comes up with a short list of the best suitable materials, and that is ranked with what we call the ExoMatter score. So based on what you're querying of the system, we tell you, or we suggest what's most useful. You can then dive into it, whether you are a materials experts and whether you know about machine learning or AI doesn't matter. It's a relatively easy to understand user interface that supports pretty much any material researcher and helps and makes it possible for you to share across your team. As I said, you put in your question, we come up with material suggestions and alternatives. So for example, what happens a lot lately is that people say, oh, we're producing this product and now we need to look into the carbon footprint that needs to be reduced. There's new regulation, or they say there's a supply shortage, we need to replace a material. Or some materials are simply not available anymore. And that's usually when they come to us and ask us for an alternative for the existing material that they're using. Then when the patents and the literature sources come up, this is often a clue for people. Say if it's already patented, they know it's likely available and easy to get. In the literatures, they can look up themselves how it's been used and what the connections are. And as I said, we have the smart weighting, which we call the sorry, that's not that. I've already talked about that. We have the smart weighting, which means that you can adjust your search as you go along, which means you can say, oh, now I see the results. Actually, costs is more important. I can see this is very costly. Or you can say, actually, if I compare the results, I'd say it's most important that it's non-toxic or that it's whatever. So you can adjust on the fly, which makes it really, really easy to handle, and you can save your searches and share them with your team. We are a company that's been on the market for 2 years now. We're based in Munich, in Bavaria, in Germany. We've actually developed as a spin-off of the German Aerospace Center, and we get support, I dare say, in various forms and shapes from the European Union, from the German government, and from Bavaria as such. And we have managed, even though we're small, we have managed to get some very famous customer logos, as you can see here. We've done work with Audi, with Airbus, with Infineon, and DLR, which is the German Aerospace Center. Our customers, when they use the platform, they report tremendous time savings. That really very much depends on what the product is, on what the manufacturing process is. But 6 to 12 months is not unusual. As I said, lots of people come to us that want to reduce the carbon footprint, and that's twofold. One, because they're reducing the materials that they're using in the labs, but the main point is that they often are looking for materials for production that have a lower carbon footprint. So there we can help a lot because we got a database embedded in our data with sustainability details. And those two criteria, the time savings and the carbon footprint reduction, obviously lead to a tremendous cost reduction, right? We're not saying we're replacing the labs, absolutely not. The labs do have their value, but what we're saying is that through ExoMatter, researchers can be much more focused in their work in the labs, and they can be much more innovative in a much shorter time. So I talked about the team, a very diverse team, fast growing, with a lot of experience, coming together from a lot of countries, and also, of course, hoping to do work with customers in a lot of countries, such as Israel, for example. And with that, actually, I mean, should we stop for questions already, or let's do that at the end once we've seen the full use cases and demo, maybe. In which case, I hand over to Sebastian to show us a little bit of the product directly.
Great, Claudia. Thank you very much. So for today, I wanted to share, let's say, a typical use case for our product, which is, let's say, one of our customers wants to find alternative metals, lightweight metals, to build frames and structures for construction, for instance, for lightweight structures in construction. So for that, of course, we want to have certain properties that we want to check for each one. So a lightweight material is translated into a material with relatively low density. We need a Poisson's ratio that oscillates between 0.27 and 0.35. That's all that basically defines how much the material will deform. A Bulk's modulus that translates into hardness, that is between 80 and 180. Shear modulus, so also just like to assess the flexibility of the materials, and Young's modulus as well, with these values that you can see here on screen. But that's only counting the physics of the material, let's say the fundamental properties of the materials. But as Claudia already mentioned, in ExoMatter, we have a more holistic approach to the material science of the material, defining new materials. So additionally to this physical properties, we also want to include other properties, for instance, cost. Cost is very important for the development of new products. So we want to have a metal that costs less than $2 per kilogram. We'll also have also a material that has low carbon footprint, because it is important for environmental reasons, but also to adhere to regulations in different countries. We also want something that it's not difficult to synthesize, so a non-complex materials, and we can limit the number of elements in the material. And of course, we also want to exclude radioactive or conflict materials, which is very important also to be able to first of all handle the materials, and also get to buy them in easy and non-politically problematic way. So with that, I would like to show you a little bit. This is how the platform will look like, but I would like to also go to a live demo at this moment. So maybe I can start sharing my screen here. Very quickly, please let me know if you can see my screen.
Yes, we can.
Good, perfect. Good. So basically, this is the first landing page of our ExoMatter platform. And what we can do here is basically let's do a basic material search with the characteristic that we mentioned already on the slides. So in this case, the first thing that we can find here on the top is the filters. These filters will allow us to filter different elements that we want in our material. So let's say for this case, we want any of the typical metals. So let's say We want to include, let's say, alkali metals as well. We want to include post-transition metals, which are the typical aluminum, gallium, indium, tin, etc. We also want to include transition metals. Then we are going to use this as our primary sources of lightweight metals. And of course, we don't want, it would be almost impossible to find a material that has all of these elements. So we're going to use materials that contain at least one of these elements. But as we mentioned already, then we want to exclude some elements. Specifically, we want to exclude radioactive materials, and we also want to exclude conflict materials. And as we can see, there are some coincidences here between one or the other, but that's the beauty of the platform, because it allows us to use relatively simple, with relatively simple clicks, which allows us to include and exclude materials, and the platform will automatically exclude whatever we want. Good. So we talked about simplicity. So here we're going to limit our materials to maximum 5 elements. At top, the data source, we can select different data sources. The materials project is a very well-known data source from computational material science. In this case, we only want to have only the most stable formations that will basically look into different compositions and only select the most stable crystal structure for one specific composition. You can also just click that out if you want to have more options. But for the moment, to filter and screen out more materials, let's leave it in. Now, let's start with filling out our properties. So the properties that we want, as we said, it was the cost estimate. We also want to get a look into the carbon footprint of the material. We want, of course, include the density. That was also one of our properties, one of the important properties. We also want the mechanical properties. So let's go here with shear modulus, bulk modulus, Poisson ratio. Those are the most important for us at the moment because of this specific use case. But we also want to have the literature references for the different materials, and we also want to know which patents are there with whatever materials we're having. So for this one, then we can give a nice name, recognizable name for our search. Let's say, let's call them alternative metals. And we can have a search here, and then we can basically start our search. As you can see here, we have a lot of other searches that have already gone through, and the system automatically queues our material search, and it starts. The platform in general refreshes every specific time, but we can also refresh ourselves manually so that we can directly see the results. And let's see what we filter out of these materials. As you can see, what we filter out in this time, it was 5,000 results. Seems like a lot, but that is because we didn't set a minimum and maximum for our properties. So from here, what we can do is set directly our boundary conditions. So we set for the cost, we wanted a material that was at the maximum $2 per kilogram. And once we hit $2 per kilogram, we will see that the material search is already filtered out almost 500 materials. Let's go with the with the mechanical properties. So we said we wanted a shear modulus between 25 and 85 gigapascal. If I'm not looking at the camera, it's because I'm looking at the list of properties that I have here. This is my cheat sheet. We want a bulk modulus that is between 80 and 180 gigapascal. Oops. 180 gigapascal, and we also want to basically report the Poisson ratio, but we can also set limits for that. Let's say 0.27 as a minimum and 0.35 as a maximum. Oops, see here is semicolon that should not be there. And with all those properties, we see that we're start excluding more materials until we have 111 results out of the 4,000 that we have excluded. Let's say now that one important feature in our search will be the maximum carbon footprint. So let's see here for this method, we want to have a maximum carbon footprint, let's say, of about 10 kilograms CO2 equivalent per kilogram of the material. And with that, we already filtered quite a lot of these materials. And we see that we have already on 48 materials from this whole list. So this is one way in which we can filter all from all this spectrum of different metals that we have with these specific physical properties, we can filter them out. Now, let's see, for these ones, interesting enough, all the options that we have here have no literature references. So this means that basically with these conditions, there are basically new materials that have not been reported in literature at the moment. What can we also do, as Claudia also explained during the talk, is that we can modify the weights so that we alter the order of the ExoMatter score. So let's say that the most important parameter for us in this case is the cost estimate. If we update this, then immediately the ExoMatter score will update and we will see which are the best candidates that have the lowest cost with the most appropriate physical parameters for our system. If you click on one of these materials, let's say the best option here, you will see that we have a little bit more detailed information. We have this chart here that basically is spider diagram, you can call it, that tells us what is the balance between all the properties that we have selected to do our screening. This is very important. It's a visual representation of how we can do this. Visual representation of how much the alternative material adjusts to the parameters that we selected. But also what we have here is in the cost estimate, we also have different synthesis routes for these materials that are calculated basically from its chemical structure. And that we have here is the cheapest one in terms of cost. This is the cheapest reaction that will lead us to this specific material. But we also have some alternative, more expensive routes with which this material could be synthesized. Similarly, for the carbon footprint, we can also have the cheapest carbon footprint for one specific reaction. So then you can select in which way is the best synthesis of these materials, balancing both cost and carbon footprint estimates. We also have more all the properties reported here and the specific individual ExoMatter scores for each property, which basically tells me how this material better adapts to our needs. So in this case, we see that the one that fits the worst to the selected properties would be the shear modulus, and that's because it's very, very close to the lower boundary condition of this material. Furthermore, what we can do is we can enrich these material properties. So what we do is with the pre-filtered materials, we can go to the enrich properties box. And in this case, we can either select different reaction enthalpies, enthalpies or reaction Gibbs energies. And that's mostly for when you want to know how the material behaves in specific chemical reactions. Or in this case, since we're dealing with mechanical and thermomechanical properties, we also want to learn about the heat capacity of this material. For this one, since it's an enriched property, we have to give some input to the heat capacity. In this case, let's say we want to know the heat capacity at 400 Kelvin. With this, we can start the search for this enriched property. And as in the same way as we did our basic search, it starts queuing. And once this is done, it will basically here give me the values that we have calculated with the machine learning models for the heat capacity of this of all of these filter materials. So we see that for 48 candidates that we have from the over 5,000 materials, then we can also have the heat capacity at 400 Kelvin and at different materials and different conditions. That we could do also with reaction properties and with other parameters that we have. And that is basically our platform in a nutshell. Very fast. Of course, all the searches that you have performed are stored here with the initial search with the initial naming that you have given. And at the moment, this is the default search, but that's probably it's going to change so that we can give a specific name for the enrichment properties search. I don't know if you have any questions regarding this material search.
Yeah, let's open it up for questions. Yes, please, David. Everybody else, if you want to type into the chat, or I can unmute you. I think I can. But we also can answer questions after the presentation because you will get our details and we can answer them one-to-one if you prefer. Sorry, David, you were going to ask something.
No, that's fine. Just when you're doing the initial search and you get the results, is there any way to sort the results through one of the parameters? So, for example, if you want to look at cost at descending order or ascending order in the view here.
Yes, as you can see here, probably, hopefully, you can see here, just next to each mean and maximum of these scores, you have an arrow, and that you can basically order by minimum cost or maximum cost of these materials. Of course, these are very exotic contributions. These are minimum cost based on the sources of the material. So they're basically the products, the reactants that will form this material. That excludes synthesis cost, but let's say we have a minimum boundary of the cost of these materials.
Right. The general ballpark idea. And then once you've built your appropriate filter, would you usually save that under a new name of the new filter, or would you export the results to a spreadsheet or any other format?
Every search is automatically saved. So as you can see here in the searches, we have different searches that we have for different use cases that we have performed. Of course, for instance, one of the very nice ones is the aluminosilicates. I can try to find it here. For instance, this one is aluminosilicates. Also thinking of materials for constructions, specifically for ceramics. We have also this material search. This one is actually a little bit more refined because it's showing only 30 results from all of the ones. Right. Why is this search more refined? Because of other feature that I forgot to mention. So the boundary conditions for each property, you can set either here in the results of the search, but you can also do it directly in the basic material search. If you select, let's say, these three properties, and once you toggle this button here and show advanced properties, so you can directly do your search with the boundary conditions, and that will limit, of course, the amount of materials that you get in there in your basic search. Right.
And can you just show the advanced search window again, once again?
Okay, yes. Let's say the enriched properties, this one.
Enriched properties, sorry. Yeah, okay. So just to understand, let's say a user of the platform identifies a characteristic or quality that's not included currently in the database in the platform. are you open to consider adding that to the database? And if so, assuming there is a source for that characteristic, of course, for all the materials in the database, what would just a very rough estimate time be to incorporate a new characteristic?
Yes, so those are kind of a two-part question. The first one is yes, so that's in the diagram that Claudia showed. That is basically let's say, the side arrow. Whenever we create a database for our customers based on the materials that we already have from public and some private databases. But also we can enrich doing new DFT calculations for more exotic or new materials that are not in those databases. That is something that we can do. The estimate of how much that will take, I will be a little bit skeptical of saying how much, because it depends on how many phases you will have for that composition. It also depends which properties do you want to calculate. If it's basic, let's say, energetic properties, that would be relatively easy. That could go in a matter of minutes once we have done the tests. But if it's more complex properties, such as thermoelectric properties, or for instance, some mechanical properties in which we have to calculate elastic tensors, that will take a little bit longer.
But maybe I should add there. So we're showing 35, 40 properties that you can search by already, and we have a very long list of properties that we're going to add to the database in the coming months. And I bet you that there's a lot of them that the audience or any user might want. So of course, we'll check, and we'll possibly be able to say, okay, in 3 months we're doing that. Always saying, actually, this is something nobody's asked us before, and then we'll have to find a solution. But there's so much in the pipeline that I think everybody will find their answers in the coming months.
Okay, thank you.
And I should also add, so ExoMatter is available on an annual subscription. So we have a fixed fee for various types of licenses. The licenses are bundled by the number of users that you want on a license, starting with 10 users and going up. So we'll find the right deal for you. But it's basically a tool that we believe every materials research unit can use as a standard for everything that they do. So we see that it's been used almost daily, and then experiments are being done, and then they come back to it, they refine it, they find another search, they want to find out about this, that, or the other. So that's the model that we're selling it in.
Okay, great, thank you.
All right, any other questions for us here? Okay, David, so I'd say if you don't have anything to add, then I'd say we close the call. I send you the recording and the slides, and then we'll take it from there.
Right. I'd appreciate if you could send me just a slide with your contact information, because then I'll add that to an email with a link of the recording afterwards. I know that some people, they were texting me while we were on the call to apologize that I couldn't join, and some of them are like big companies where a few people had to come in. So I'll just, when I'm sending them the link to the recording of the presentation, I'll include the slide with your contact information that has the QR code and the details, and then they can contact you directly. And also to Rotem and the other persons on the call, please feel free to contact Claudia, Barbara, or Sebastian directly if you have any questions about the platform. And
Great,
online, of course, it's ExoMatter.ai, and there's more information there as well.
All right,
Okay.
thank you very much.
Thank you very much.
Have a great day.
everybody.
Thank you
Thanks,
very much.
David.
Bye-bye.
Bye.
Bye-bye.